Hola. Hello. Good morning. Buenos días. I'm Rebecca Collins. I'm a lecturer in contemporary art theory from the University of Edinburgh. And I'm here for 1 year with my project Parametres for Understanding Uncertainty, or P4UU for short. And I'm delighted to welcome you all here today to the Theoretical Physics Institute at the University Autónoma of Madrid. The session today is going to be in English, which is a change from the other two sessions. If you want me to speak more slowly or a spontaneous translation, do raise your hand and I will do my best. Can everybody hear me okay? Brilliant. Okay. So I'm going to introduce today's session, which is on methodologies for discovering the unknown. And the main area that we're going to be thinking about and discussing are ways in which you might investigate something that we don't know yet, or we don't know the ways to necessarily find it out, both within artistic experimentation and also within scientific experimentation. We're going to ask questions about how you might go about creating a project to think about and discover what is unknown, but equally we're going to think about the reproducibility of such project structures and infrastructures, the type of institutions that you might work within or find ways to connect with, different types of uses of the imagination, different types of uses of experimentation. Think about a little bit the value of this work when sometimes when you're going towards something which is yet to be known what might happen or what the outcome might be, it can be difficult to convince funding bodies. It can be difficult. You can have a lot of bureaucracy to deal with, and some of those also. So some of the sort of more exciting questions around imagination and experimentation, but also some of the more kind of mundane issues around what does the day-to-day aspect of that look like. So this is the third of 4 sessions, and the idea behind these sessions is also to encourage discussion and questions from people who are in the public. So we will have some time to ask you questions and for you to ask us questions. So you know, wait for that, and we'll also have a more informal moment at the end for biscuits and coffee, so worth sticking around. So the previous 2 sessions, the first was on uncertainty and indeterminacy in the work of John Cage from the arts and humanities side, and also thinking about the uncertainty principle within physics, and that was with Esperanza López Manzanares and Carmen Pardo Salgado. And the second session was on membranes, microphones, hydrophones, and particles with Miguel Álvarez Fernández, who also joins us today, and Miguel Ardid. Both of those talks were documented by video and can be seen on the Institute for Theoretical Physics YouTube channel. So do take a look at those if you've not had a chance so far. So, without further ado, I would like to introduce our speakers today. We're in very good company. We have with us here Ariane Koek, who is an independent producer, curator, and writer, recognized internationally for her work within technology, arts, and science. Most famously, perhaps for many of you, will be the work that she initiated in 2009 with the artist residencies at Thurn. And she continued to work there until 2015, and importantly putting in place kind of sustainable structures for that to continue. And many of you will know that continues and is a very, very successful program. So we're delighted to have Ariane here with us today, and she's going to talk more about some further projects that she's continued to develop and her way of working. We're also joined by Maria Luisa Salsa, who is Professor of Atomic, Molecular and Nuclear Physics at the Department of Theoretical Physics in the University of Zaragoza. She is the principal investigator of the Anais experiments, which is in the underground laboratory of Canfranc. And I had the pleasure of visiting this laboratory recently with her. So today we're going to do a slightly different format, of course, to the other 2 versions. Ariane and Marisa have invited me to be the moderator, so I have accepted their proposal. So we're going to, I'm going to play the role of interlocutor, and we're going to move hopefully quite fluidly between a series of topics. David Cerdeño, who's my scientific host for the project, is going to play the role of the technician. Thank you, David. And I'd like to thank David Alonso for helping with the furniture rearrangement, and Laura Marcos Mateos for the camera work, and obviously to the senior management at the IFT for continuing to allow me to do these types of activities, and also to the funders, the Royal Society of Edinburgh. So let's begin. Just a costume change. Okay, so we'll start with methods and methodologies. So I've been thinking a lot about artistic investigation, but also investigative processes in physics. And I think about how sometimes things don't become a product, or you don't get the results that you want, that you might find nothing, that you might find what it still isn't, particularly within dark matter detection. And often also within artistic investigation, the process is what can create knowledge and can be part of the experience. And something that really struck me in Ariane's writing was her description of how she set up the artistic residencies at CERN, and how really the emphasis was on the process, not the product. I mean, products did come out, but I was very kind of taken by that. You know, we might think about the manner of doing something as actually part of the knowledge-making process. The ways that you set up an experiment, the types of material, the length of time that you where you put it. All of these decisions are a really important part of the work, the modes of doing. And how do you begin? Maybe you begin with an inkling, or an intuition. Inkling, I don't know the translation of that word, I'm sorry. But an intuición, something intuitive that makes you think, let's try this, or let's try it this way, or maybe this is possible, which are also perhaps leaps of imagination. But I'm particularly interested in how you start from this interest of there is something that I want to find out, and how am I going to do it? I don't know exactly what it is, but there's this explorative attitude. So my first question to bring both of you into this conversation and to this way of thinking together, I really wanted to ask both of you about the modes of doing that you have found for carrying out your research, and if you can find ways to describe this for us today. So I think we might start with Marisa on this question. So welcome, Marisa. Thank you so much for coming. And
thank you for inviting us.
Over to you.
It's a pleasure. Okay. So maybe I won't answer all the things that you have proposed. Maybe in the next intervention. You cannot hear? Okay. Okay. So, okay, I try to speak louder. So, in principle, the method of science is quite well known, and I think that I have just to remember, and I will use the words of very important scientists and physicists in particular. What we are trying to do in the end is that we are observing the world. So, what we can do is watching the play and try to take out the rules of the play from this observation. So, and in principle, these rules of the game that are there, and we have to find them, is what we call as fundamental physics. And the most important part of this method of science is that we have to do questions. So we have to ask all the time, why is this happening in that way or in a different way? And then curiosity really is very, very important in the method of science. So we need this. But we don't only need to make questions and to do observations. With this, we prepare hypotheses, we do tests, results, and we frame all of this inside theories that are trying to explain what we are observing. And this is really very important because the physical theories are always provisional. They are hypotheses, and only one single observation that disagrees with the predictions could take down a whole theory. So this is really very important in science. So we know continuously this provisionality of our knowledge. And I will put you an example that is related, of course, with my work, how to face this unknown that is there. And in this case, we have looked at the universe from the larger scales and also to the smallest particles in the universe. And we have really a very good theory to explain a lot of things. However, we cannot understand the universe. It's really still a puzzle. So there are a lot of questions that are not answered by our present theories. And in fact, really, for instance, we know that there is some invisible ingredient in the universe that is dominating the universe evolution and history. And how we can find something that is invisible? How can we learn things about an invisible part of the universe? So we need to look in different ways. So we need to explore different ways to look at the things. And in this case, for instance, how do we know that there exists this matter? It's because we have been able to make measurable things that before couldn't be measured. And this developing of new tools to do the measurements, to do the observations, are really very, very important in science. Developing tools is one of the most important things in science. In this case, for instance, I show you how we know the mass of the sun. We know the mass of the sun very nicely because we have observed the motion of the planets around the sun. So we have observed that the planets are going faster or slower around the sun, depending on the distance, but in a precise rate that is given by the mass of the sun. And so then we can understand the solar system, but we don't understand in the same way the spiral galaxies. In the galaxies, when we look at the stars that are moving around the center of the galaxy and they move really too fast. It's like in the picture, we were losing the man that is going round, make round the stars. And so this is our question. Why do the stars are moving so fast in the spiral galaxies without the mass enough to do this? We have to think that this is an invisible mass, and then we have to try to fit this into our theories. In this case, science, what it's doing is always to stand on the shoulders of the previous scientist. And so then we have to ask ourselves if this problem had happened before and which were the answers from the theories before. And in this case, we have found similar problems in the past. We have had some problems, for instance, in the orbit of Uranus that was not understood, not explained by the Newton's law. But we found a new planet. Neptune was found there where the calculation of the mathematicians predicted it should appear because we were confident on the rules of the dynamics, and then we were able to see a planet new that was not previously seen. However, the Mercury's orbit, that was also not well understood, was not explained by another planet. It was explained because we have to change the theories. We have to develop the general relativity theory to understand the Mercury's orbit. And so then now we are more or less at this level in the problem of the spiral galaxies and many other evidences in the universe. So in principle, we have the two options. Galaxies could be composed of this invisible halo of dark matter, that is called this invisible matter, that should be really very large with respect to the normal galaxy, but it's also possible that we should move to a different theory, and our rules of the game are not good at this moment. And this is present, for instance, still the situation, that both ways are being explored by science, And in principle, I will comment later, because it's my work, the first option, that there is this dark matter, this invisible dark matter, in the galaxies. But, of course, we have to be conscious that there is not only one answer to any question, and all of them have to be explored. I think, I don't know.
Great, thank you. I'm going to pass this to Ariane. Thank you so much. That's really interesting, Marisa, in terms of the kind of provisionality of what one might know, the measurability, things that leave kind of clear gaps in knowledge that need to be solved ultimately, and these kind of the ongoing mystery of dark matter, I think, never ceases to kind of provoke the imagination of artists in particular, but I think also, to stimulate the minds of physicists and to really. It's just it'd be really incredible that at some point to know more about what that is. But certainly it's interesting to understand how it's through the different masses and through those things that you can't quite explain yet or account for that become the sort of impetus for this search for the unknown. So we're going to move seamlessly over to Ariane so asking you really the same question, but from maybe very different perspectives and with very different tools and ways of thinking about the sort of modes that you've found for carrying out the work that you do. Please go ahead and tell us a little bit more about how you do what you do and this sort of pioneering way of working in these different institutions and with a number of different people in different ways and different minds.
Art is a completely different way of knowing. It is a way of knowing, but it uses all the senses. It's not dominated by the eye in terms of observation. It uses smell, touch, all the different senses which we have, the five senses and more, because we have more than five senses. Intuition, for example, is a sense, proprioception, balance. So I think art is incredible as a way of knowing because it's very holistic. And it's always going into the unknown because that's why it exists. It's a way of exploring. And certainly in the work I do, some of the work I do, so particularly for example, with physicists and artists, Fabiola Gianotti, the Director General of CERN on the right, Haroon Mercer, the artist on the left. I believe very strongly that artists and physicists are twin souls in a very wonderful way, because they're all going for searching for the unknown, exploring the unknown. They just do it in different methodologies. As you know, some of you, physicists are experimentalists and theorists. Theorists going beyond the paradigm, and then experimentalists bringing that down to earth and testing those hypotheses out. That's what an artist does, actually, both. An artist combines both those things, thinks beyond with their senses, with all their different senses, and then brings it down to earth by creating something which might be invisible, might be sound, like Rebecca's pieces. It might be something completely different. And that's probably why I love working with physicists and artists in particular, because I feel there's a really strong affinity there of exploring the world together in that way. But what I do in the work, and certainly when I founded Arts at CERN and initiated it in 2009, I made sure that it was all about, as Rebecca said, about process. It wasn't about fusing art and science together, combining them. It wasn't about art describing the science or illustrating the science, so being a servant. It was about them being equal partners together and colliding the imagination of artists with scientists who have imagination too. We'll come on to that a bit further because I've got some theories about what's happened regarding science and imagination. That, as you know, is one of the big detectors at CERN, CMS. I don't know why I put it there. Anyway, but Arts at CERN has had many different ways of working with the imaginations and with artistic practice by colliding artists and scientists together, by having discussions together. And we've done everything from being on the Paris catwalk, inspiring the fashion designer Iris van Herpen to do one of her collections, which was inspired by gravity and learning about gravity, to, on the far right, a piece created by the dancer and choreographer Gilles Jobin, called Quantum, really inspired by quantum physics, and danced literally above the spot where the Higgs boson was detected by the CMS detector. That's just a photograph of CMS behind it. So one of the methodologies, which I would love to say about art and science working together, is both the artist asks the impossible and the science organisation, the scientists working with them, have to respond to that impossible and have to be curious and playful. And I think one of the most ultimate challenges I ever got was when Bill Fontana, the sound artist, he explores everything through sound, said, I want to play with the Large Hadron Collider. And can you imagine being given that kind of challenge where the world's most expensive, most delicate machine is being asked to be touched by an artist and actually have equipment put on it, accelerometers. To the great credit of CERN and to Frederick Baudry, who was the director of the Collider at the time, they said yes. And I'll just do a little, I think a little film. So we just have a little film of that now, which I will. Thank you. So yeah, there you have the Large Hadron Collider listening to itself and having it played back to itself as an artistic experiment and an artistic intervention. So I think the great methodologies for art and working with science, as I said, is mutual curiosity, mutual playfulness, openness, and just the love of discovery and exploring and going beyond any known parameters, including practical parameters like playing the Large Hadron Collider and making sure those things happen. And I suppose one of the things I also love is physicists once said to me, "Oh, Ariane, we just always run at walls because if you run at walls, at some point, theoretically, there's the possibility the wall will fall down." And I kind of feel like that when working with artists and scientists, that we just keep on pushing those parameters, exploring things in different dimensions and creating new ways of understanding, responding and connecting with our world through art. Yeah.
Great, thank you, Ariane. Wonderful to see that video as well. And I believe he then went on to make the piece acoustic time travel from that sort of exploratory moment. Yes.
Yes, he did.
Oh,
yeah,
great.
Which has been shown. Yeah.
Brilliant. Yeah, I think, before we sort of move on to the next section, I was just thinking, kind of going back also to what you were saying, Ariane, about it's not about art being in the service of something. I think it's really interesting the way in the program at CERN you were able to create a space so that wasn't the case, that actually the artists were there to explore, to ask questions, to engage with the physicists. And it's, I think there's something there about not having a certain pressure to deliver information or to kind of give a certain message, but a kind of freedom within and a playfulness, absolutely. And I think one of the things I've been thinking about, and also with some other people who are in the room today, is this idea of kind of speaking closely to something as a way to find an angle to approach it. Because sometimes if you try to directly represent, particularly within artistic practice, it can be quite difficult or problematic because it's sort of making a copy of the thing, which sometimes it's very difficult also to make a copy of what a thing exactly is. So I've been thinking about that, and also thinking about when you're within an institution, how you're working with the people within the institution, and you've named some specific people, and that those are, you know, very much also part of the work, those relationships, that kind of act of trust building and negotiation. You know, how did you convince them to let Bill Fontana play the Large Hadron Collider? I would have loved to have been a fly on the wall in that conversation. How do you approach something like that? I don't know if you can say a little bit more about that type of, because that is also work.
Yeah, so I mean, curators are very used to that. So I'm a curator producer. So you make things happen, and it's very much about relationship building. So getting access to the LHC, or for example, recently I worked at the world's deepest diving pool in Europe, actually, which is just outside Italy, and I persuaded them to work with us on another artistic experiment, which I'll talk about later. It's all about relationship building and winning people's trusts and hearts and minds, and being open, curious, and playful, and persuading them to give me access to the Large Hadron Collider. Obviously, it wasn't switched on, otherwise I wouldn't be here, and we wouldn't have done it, and you wouldn't have heard anything, because we'd all be dead. So that was one way of persuading them. So you do that in a very playful way. But also, it's about... I just think, again, as I said, physicists are explorers like artists. And I appealed to their exploration. I said, look, come on, let's do a first. You do firsts all the time. Why don't we do a first and play the Hadron Collider back to itself? Why not explore this? We have this opportunity with a great artist to explore this as a possibility. And you don't like having boundaries, so go for it. And I suppose I was very lucky because, CERN is a fundamental research laboratory, so it's there to look at fundamental research. It's not directed research. So they were super open to that, and they have super open minds, and so I was able to appeal to that spirit of adventure. Yeah.
Great. So we're going to sort of work our way into the next section of this morning's discussion, and I've been thinking a lot about knowledge, what knowledge is and how knowledge unfolds in different places and in different ways, and how theory and practice are linked together. Often thought of as perhaps separate domains, but I think often in error, because really, it's in the act of doing something that you begin to understand it, or begin to understand what it might not be, perhaps. I think about that a lot in the context of your work as well, Marisa, and what I understand about how the Canfranc Underground Laboratory works, and the very idea to begin to look for dark matter underneath a mountain in the Pyrenees. It's a very, very compelling act of imagination on one level, but also that sense of not knowing a priori, to doing all of that work and setting up the infrastructure that has taken, since the 1980s, as I understand it, to really be what it is today. So it would be really interesting, I think, to hear about the role of imagination and experimentation in the work that you do.
Okay, so as I commented, the problem of this invisible matter in the universe is quite complex, because it should be not only invisible, that means that it's not interacting electromagnetically with the normal material, but it also should be very weakly interacting. But it dominates the universe. So you have here the universe recipe according to the most recent evidences in the observation of many scales and times of the universe evolution. And the visible matter, the normal matter we are made of, is only 5% of the universe, and the dark matter should be around the 27% of the universe. So in principle, understanding what is the dark matter is really interesting, and is one of the challenges for fundamental physics. But one has to imagine which are the properties of the particle that could explain this invisible mass, because we are only observing the evidence of the existence in the universe. That is far away. We have no direct contact with these particles, so we have no direct way to experiment or to explore the nature of the particle. So we have to make some research, trying to fit all the properties of different particles with the evidence that are observed in the universe. And of course, there is not only one answer, there are many possibilities that are able to explain this. But none of them is inside our present particle physics standard model. So we have to look for particles new, different from everything we know. They are different from all the particles composing the protons, neutrons, atoms, molecules, and all the rest of the matter. This is the standard model of particle physics that explains quite well up to now everything that we are observing here around us, but not the dark matter. So the dark matter should be just like an alien, something quite strange in our present understanding of physics. And of course, this is important because we have to have the possibility to imagine new particles with the right properties. And in this sense, it's not only that we need new particles, we need also to design experiments for detecting these new particles. And this is quite interesting if you don't know the properties of the particles, so the experiment is complex. Because maybe your experiment is not convenient for the real particle, and then you have a lot of uncertainties in the work your experiments are done, and the results that we'll obtain. So we know from beginning that most of the experiments searching for dark matter probably won't find the right dark matter particle. So this is also important when designing science and the scientific process. But in principle, we expect that the particles interact, although weakly, with the atoms of our detectors. So then we explain that the small amounts of energy could be released to the material our detectors is made of, and then we have a possibility to detect some of these particles. And this is the approach that we have followed in the direct detection experiments, searching for dark matter, that we are waiting that these particles that are around our galaxy come to our lab, come to our experiment, and then release a small amount of energy. So for that, of course, we cannot be in a place where there are a lot of many other interference. We have many other particles here now coming from cosmic rays, coming also from environmental radioactivity. And so then we cannot do these experiments searching for very strange particles with a very low interaction probability in a normal laboratory. So we have to hide from all these particles. I don't know if you see this. If we want to see something very small and weak, we have to develop techniques to hide all the other interference. And because of that, underground laboratories develop. There are only a few in the world. I put here some map with some of them. Now there are in construction a few of them, a few more. But in principle, they are quite complicated facilities for doing science. They are inside mines or inside tunnels and covered by the mountain, as is our case. In Canfranc, we are in the tunnel that is crossing from Spain to France, that in the old tunnel that was not in use, we could put our laboratories in the 80s of the past century. And now there is a large laboratory there that is profiting from the umbrella of the mountain that is stopping the cosmic rays. So we use really the mountain as a protection against the cosmic rays, and then we are hiding our experiments from a part important of this interference for the searches of strange particles. And then these new infrastructures have to be imagined before we could build them. And now there are many different physics experiments related with particles like neutrinos, and also other rare processes, not only dark matter, that are being developed in these underground laboratories. But also we have to protect our experiments from radiation. So this is just a sketch of my experiment, that is the ANICE experiment. This is an artistic view of the setup. You see the different parts that are taken out. Every part of this shielding, this protection, is to avoid a different particle coming into our detectors. Here are the 9 detectors of an ANICE experiment. And so in this case, we have to stop the photons, the neutrons, and we have to use very poor materials. So developing techniques that make possible to do the search for dark matter is really very important in our work. And then when you have designed your experiment, then you have to start to take measurements and then to analyze the data and to try to understand if you are seeing dark matter or you are seeing something that has passed all your controls, and that of course is really impossible up to now to have a zero radioactivity background. And so the experiments are still trying to do this. But the sensitivity has improved a lot, and so a lot of dark matter searches are going on in the world. But these detectors, that some of them are impressive. This is not an ICE. This is one of the xenon detectors that are, this one is, I think, Rasaso. Very sensitive detectors have been developed with the time. They are impressive. And okay, maybe dark matter won't be found by them, but the techniques developed could be applied to other purposes. And for that also imagination is important, because we are developing tools for one goal, but maybe there are many other goals that they could be used. And this has happened many times in the science development.
Thank you, Marisa. I'm really struck by the way you describe designing science and the design of the experiment, and of course this incredible video where we sort of see the different layers and the kind of thought and imagination that goes into designing that, and the use of copper in particular. It's copper, right, that I see in the
coverage of our detectors is copper. Yeah, because it's easy to obtain it with radio purity.
Easy to obtain it with radio purity. Yes. So yeah, it's just that it has a kind of aesthetic appeal to it that is quite seductive in a sense. And this protection from the cosmic rays. So this kind of, we might think of the cosmic rays and these other types of interactions as a kind of noise interference. I guess that might be a way to describe it. So that's really what you're sort of have when you're designing this. And when you're working on the design, is there a team of people that you work with to think through the different? Do you work with designers? Do you work with engineers?
Of course, we work with engineers. Yeah. Yes. This is really mandatory to combine the technological abilities with the scientific ones, and in experimental physics, it's.
Brilliant. Thank you so much. I'm sure many people here have many questions that we'll come back to a little bit further on, but it would be good to bring Ariane in here to speak to the idea of imagination and experimentation and, thinking about how the work that you do is often engaging the imagination to a very kind of large extent. You're really taking these ideas. We saw some images earlier from the catwalk, taking ideas from physics into fashion, and the work with Bill Fontana. And I think there's something about re-enchantment, of the unknown that kind of comes through in some of the things that you've been doing. So it would be good to hear more about your work.
Okay, so I believe the imagination is humanity's superpower. It's their ultimate superpower. It helps us, whether we're scientists or we're artists, to go further and reach beyond the stars, literally, into new places, connect with new places and beings which may or may not exist at all. I can't think of anything more extraordinary that humanity has, to be frank. It's also a way of creating empathy through connection. I'm just going to flip through the slides very quickly to a piece by the artist Sarah Say, which is called Dark Matter. So Sarah Say's response to thinking about dark matter it's an incredible piece, which is very, very tiny. It was in my show. I did a show in Sweden called Entangle, Physics and the Artistic Imagination, and Sarah's piece was in it. So if you imagine that very, very small, so I'm asking you to imagine, and then there was a lamp over it. So in a way, it was an ironic statement, response to dark matter, because as we know, dark matter is not detectable. You can't be seen by light. And also it's a kind of ironic reflection as well, because these little fragments drawn from images from the material world are suspended, so they're kind of gravitational. So it's kind of response again to the properties and the understandings of dark matter. So that's a way of showing a kind of imagination of an artist in action and how that goes into a new place. I'm just going to flip back. I can't flip back. I'm going to have to go ask David to take me all the way back to the beginning, and then I'll work out where we are. Oh, yes. Might as well do this. Mary Shelley, extraordinary 17-year-old who responded to the science of the time, galvanism, because it was thought then that electricity was perhaps the fundamental force and sparked us all into life. Her imagination took her to the point where she created the monster Frankenstein. Well, the monster. No, it was Frankenstein who created the monster. They always get conflated, even in my mind. So again, that responsiveness to thinking about physics, responding to physics or science can take you further. And I'm always struck by Albert Einstein when he said knowledge is limited, whereas the imagination embraces the entire world. That's also why I also talk about the imagination being a time travel, a form of time travel, space travel, taking us beyond our material universe. So a piece I worked on recently, we were working with climatologists who are drilling ice cores in Antarctica, and the ice cores obviously hold the bubbles of the not the universe, the bubbles of the Earth's environment inside them, the chemistry, which can be recreated from the bubbles up to 2 million years ago. And Carlo Babanti and his team are creating this extraordinary library of ice as part of the Ice Memory Project, as a library for tracking climate change. And it's going to be stored in Antarctica, a neutral political place. So how do we get from that to this? So the answer is, this is a work called Witness by the artist Emma Critchley, who was artist in residence at Science Gallery Venice at Ca' Foscari University, working with the climatologists. I was the curator enabling that to happen. And it was her imagination which took us from the ice cores to the world's deepest diving pool, and me who practically brokered that relationship to make it happen. And we dropped dancers who'd never been underwater into a swimming pool, but having trained them for a week, I have to say, they weren't just dropped, and created this extraordinary multidisciplinary installation. What you see there is only one screen. We've shown it at the Brighton Festival recently with 3 massive screens with live performance as well. And Professor Carlo Babanti was really intrigued at the beginning of this journey, because he was like, why are you going to a swimming pool when we are, we're talking about ice cores? How does this relate in any way? And the beauty of the artist's imagination is it takes you and the science further. And when we played the final cut to Carlo Babanti, he went, oh my goodness, I get it, I understand. And he also went, he actually couldn't speak for about 5 minutes. And then he went, that was awesome, because it touched his heart. And he saw that what we were doing was making a link between the body of the glacier. And as we know, about 85% of those glaciers are now on the planet are dying. are classified as dead, and there have been funerals actually made for them in Iceland, for example, as though they're a dead person, and people talk about the body of the glacier. And so the body of the ice was reflected in the body of the dancers. The shape of the pool, which is actually like an ice core, it's incredibly deep. It's the world's deepest diving pool. No, third now. It's been displaced by 2 others. It's like a giant cylinder. And so the shots, which you will see intercut between the ice cores and the pool, again, building connections. So imagination is an incredibly connecting, extraordinary force. And yeah, I can't think of anything which humanity has which is actually better, which also links science and art. And I think it's wonderful that science is being more explicit than it used to be about the inclusion and the power of imagination as part of its methodology of discovery, because previously, when there was the big split off in the 17th century with the Enlightenment kind of creating a methodology for science, the natural sciences, and alchemy was banished as the irresponsible, the irrational, the unmethodological, because it was too imaginative. There was a kind of squashing down of the idea of the imagination in science. But now, and it's lovely listening to Marisa explicitly acknowledging imagination as part of the process of making science. Yeah.
And do you think, Ariane, that the imagination is something that we need to train? Do you think that it is something that we, is it a place that we go to quite easily, or do you think that that it's trainable, or that we should train it?
Training the imagination. Ah, wow. Okay, so yes, well, I just think playfulness. I just think we have to be open to be more playful, and playfulness makes you more imaginative because it takes you beyond things. Can it be trained? I think there are ways of sparking and creating imaginative encounters, such as even just going to art, just going to see a piece of art and feeling your body respond to it is a way of sparking your imagination. When your body, your mind, your heart, your intellect all start going off in different directions, that's when your imagination is really time traveling and taking you further. So that's also the power of seeing and being with art, I think. And that's one way of training it. And another way is just to be open and playful. Yeah. And experimenting. Yeah,
it's interesting in the piece, because you're talking about ice and you're talking about this place that's far away, but actually you go to a swimming pool, something that's maybe more known or more familiar, but then the way that you approach it is less familiar. So I think there's something also about perhaps assuming that we know the known, but perhaps there's something unknown within the known and within the everyday as well. And I did actually want to just make a light reference to an artist, a British artist, sculptor, writer who passed away this week, Brian Caitlin, who was a particular incredible force in terms of the imagination. If you're not familiar with his work, there's an excellent documentation of his work online, and I would encourage you to look at that, because he definitely kind of thought about that in terms of what's within the known, what's the unknown within the known, and how to kind of unleash that. And really, his work across sculpture, performance, and writing was very much engaging the imagination in a number of different ways that I think is a kind of force that is useful, particularly I think in sort of increasing times of more and more kind of other types of work that we need to do that might relate to bureaucratical types of administrative labour and so on. But I think that there is certainly a space to kind of question the stability of what we have around us and what we think that we know, but we are still kind of yet to really know, or to know in different ways. I think that's kind of important. So I wanted to maybe move on to think about reproducibility and value. And something that really strikes me in your work, Marisa, in the experiment at Anais, is, from what I understand you're doing there, is setting up the experiment to try to reproduce the results of another experiment that took place in an underground laboratory in Italy, in Gran Sasso. And this, to me, feels like a really brave and bold choice, and perhaps kind of slightly unpopular in terms of its endeavour to find a way of verifying what one experiment has found with your experiments, rather than maybe pushing a new limit all of the time. It's kind of trying to do this kind of social reproductive kind of action of, okay, can we really, are these is this data that we have, is it possible to reproduce it in our laboratory? So perhaps, and what is the value of that? Is that recognized? Is that seen as a different type of labor to maybe experiments that are trying new materials or new ways of searching for dark matter? So it'd be really good to hear from you on that.
Yeah, so reproducibility in science is really the most important thing, probably. So one can never take just one result as a proof of a theory, but also one result is also not enough many times to say many things if there are no ways to reproduce these results. So then this is really very important. But of course, the experiments that are providing results beyond what we expect are always more interesting, because there are maybe the doors into new lines of new theories, or something that was not put in evidence in the previous theory. So for me, then, reproducibility is very important, and in the case of dark matter, there has been a trouble or a puzzle for more than 20 years, because there is one experiment that is observing something compatible with dark matter for 20 years. So this is the experiment Dama Libra, that is in Gran Sasso Underground Laboratory in Italy, and they work with 250 kilograms of sodium iodide thallium detectors, and really the argument that they have detected this dark matter is here in this plot. You see this modulation along the 20 years. So this is an annual modulation in the data. They observe more events interacting with their detectors in summer than in winter, and in principle this is exactly what we expect that the dark matter is doing. I comment you briefly why. This is because the sun is moving around the Milky Way at 230 kilometers per second, and the Earth is going with the sun in this travel around the galaxy. But the Earth is, along the year, is going sometime around the sun, and part of the year is going in the same direction, and the other part of the year is going back. And this makes this modulation, and we expect the annual modulation in the detection rate of dark matter particles, because in the end it's like we were moving inside a cloud of particles, this dark matter, and it's our motion which makes the particles come to us, just like in a motor. If you are going in a motorcycle in the and you are crossing a cloud of mosquitoes, for instance, so then you will get more or less depending on your velocity, and the effect is expected, of course. But no other experiment in the world in these 20 years has observed nothing compatible with Dama Libra. So then what happens in this case? Is really Dama Libra the door into new physics? Is just an experiment fail that the answer is not important? And the question is that all the other experiments were not able to completely discard the experiment Dama Libra, because the other experiments are using different detectors, different materials, and we don't know what is dark matter. We always can imagine a particle that could produce a signal in the detectors of Dama Libra and not in the others. So the answer to what is happening here was somehow complicated. And because of that, Anais, that is the experiment I'm working with, tried to use the same detector in a very similar detection approach, but in a different laboratory with different analysis techniques, trying to understand if this is a systematic effect or is really a signal. So if Anais would observe the modulation, then we probably will have to take very seriously this result. But this is important to answer these questions. So Dama Libra has been there by 2 decades. This is really a very long time. A lot of experiments have been doing experiments much better and improving sensitivity. So why had never before tried to reproduce Dama Libra? So I can tell you that it's really very difficult to get funding to repeat an experiment that already exists. So this is not easy to do because, okay, confirmation of something is not a discovery. And then the funds you get are always more complicated to get, and also the award of the experiment is not the same. And I think that this is one of the reasons because other important collaboration in the world that had much more money than, for instance, in our case, could have done this before. And it was not done, okay? So this is a problem. So reproducibility is there, has to be done, but who does? Okay? Yeah. So this is clear that is not a problem. Of course, there is interest in the world. We presented preliminary results. Now we have already finished our 5 years of data taking, and we expect to present more results very soon. And we will be the first to test Dama Libra with the same target in a model-independent way. So in any case, it has been really a lot of effort to get the funding and the way. And we are not seeing anything up to now. We have not still analyzed the 5 years, but with the 3 years, we don't observe the modulation. And so now, how to decide which result is right? So now it's like a fight, Anais versus Dama Libra. They have more data, more years. This is a question of credibility, peer review, transparency. Science is complicated also in the decisions, in the taking of decisions about these things. But I will say that nowadays we have stronger tools. Transparency and open science is probably entering, I hope that soon, strongly in the field, because we need to have better instruments to decide who is right or who at least is doing better the experimental part of the problem. In our case, of course, if there were only Anais and Dama Libra, is 1 against 1, but there are other efforts in the world. This is more or less the experiments that are trying to reproduce Dama Libra. In principle, now we are only in data taking phase, Anais and Kosain in Korea, but there are other projects maybe for the future. So there will be more pieces of information about this question. In any case, as I commented you before, it's not easy to say how will the problem be solved, because not only maybe our experiments that we think that we are doing correctly and that we have been quite designing the tools and the analysis as best as possible, but probably it won't be just by this completely solved, okay? But I will also to comment here. No, what is the award for? So probably who discovered dark matter will get a Nobel Prize someday. Could be, but it won't be probably fair because science today is not done by one person. So these prizes that are provided only to one leader or to one thinker, I think that are not going with the field. So the physics is done by very large teams, but a lot of people that are collaborating. And I think that this is really very good, and the message should be that we have to find new ways to award the people doing the work, the people working in the teams, that we really need to think that this is important, and that it brings also very interesting things to the process, that there are so many people working together. And I think that this is something really important in present science.
Thank you. Yeah, just move this across. Thank you, Marisa. It's fascinating and really generous of you to share that with us. And just to really think about the value of reproducibility and that struggle for funding, which is, I imagine very, very, very real, and also to think about the sharing of data and what data gets shared and which is kind of kept private, and sort of beginning to understand different European strategies, I think, for sharing data in different ways and to share it more openly. But I just wanted to ask that the graph that we saw, from Dama Libre. Is that to suggest that dark matter is kind of seasonal? That there's a kind of is that if I'm interpreting it correctly? Yeah.
Yeah. Dark matter particles prefer summer than winter.
They prefer summer than winter. That's good to know. Yeah, I was noticing that as we go into autumn, there's less dark matter around. Perhaps other people in the audience are sharing that too. Brilliant, thank you. Yeah, it's really interesting to see all those different experiments as well, and also some that are in Australia, so the sort of other hemisphere. Yeah. So maybe thinking about that in terms of where the experiments are situated, if there's a different sort of hemispheric difference.
Yeah. One of the issues, systematic issues, is temperature. That of course is always higher in summer than in winter. And to decouple this from the problem, then some experiment in the southern hemisphere could have helped. But there was no underground laboratory in the southern hemisphere. And in my map, in the previous map, you could see that there is no one in the southern hemisphere. This has to do with many other things. This is economics, and the countries well developed are most in the northern hemisphere. But now the Australian people is just finishing one underground laboratory, and this Sabre experiment will be one of the first one to be there.
Yeah, of course. Physics experimentation is not operating outside of political and economic and social infrastructures and complexities. So yes, of course, it's not just sort of existing within its own bubble. So of course that also has an impact on what you can find and how you can find it. Well, there's lots to think about there. Maybe we'll bring Ariane here to also think about how reproducibility and value operate within your work and within your practice. And of course, it's really, as I sort of said earlier, it was really compelling to me that within the work that you did at CERN, that there was, it was important to you to have a legacy for that work and for it to be a kind of sustainable project, in that sense that there was a way for it to continue, for you to sort of pass the baton on to the next person, and that it continues to be such a kind of landmark program for artistic residencies is all to your credit and to your hard work there. So it would be interesting to hear perhaps whether that was one of your kind of core objectives when you set that up, and also how things can shift, obviously, when things move from one person to another over time, how things shift, different funding schemes that pop up and disappear, and we're in a very dynamic, fluctuating landscape, and particularly even more so, and just sort of within the UK in particular, I think right now where there are some real questions around funding and sustainability of art schools, of university programs that are really quite concerning. So it'd be really interesting to hear about reproducibility and value within your work, Ariane.
Okay, there's a lot there. Okay, so reproducibility is so fascinating because in contemporary art, reproducibility actually has lower value than the original. So it's a bit like the discovery in a way. The discovery in science has the prestige. The original in art has the prestige and the monetary value. And the copies don't have the value in contemporary art. Obviously, replication does happen, reproducibility does happen if you're doing performances. Those have to be reproduced, but still they have to be works which are deemed to be original, which break new ground, which go in new directions. Obviously, Andy Warhol did a whole commentary on the rise of technology with the Campbell soup can, saying, look, we're in the era of reproducibility now. We can reproduce anything due to technology. And that piece, which ironically is now one of the world's, highest valued pieces, which is another irony, was a commentary on how technology has taken away reproducibility, and the very famous essay by Walter Benjamin about originality in the mechanical age of reproduction was talking about that as well, saying, have we got beyond the original as a source of value? The answer is we haven't really, and it's kind of morphed itself into another new way through the NFT things which have come up. And NFTs are quite extraordinary because, as we know, they kind of pull on creating originality in a digital form by changing one little tiny element in each digital artifact or NFT work, so that they become original. So there's infinite originality by changing just a little tiny weeny thing. So originality as a kind of doctrine in contemporary art kind of continues, ironically now, through the NFT digital route, which is opening up a kind of, it looks on the face of it as though it's an original, but it isn't an original, because there'd be some tiny little pixel or something which is very, very different in the coding, which will make it original. So that's quite fascinating. In terms of artistic programs and in terms of the CERN program, for example, I very much believe you cannot reproduce any art program in any science institution. Every single science institution has a very different dynamic, has a very different culture, has a very different way of working. So I've always said to people, do not copy arts at CERN. You cannot cookie cut. You cannot cookie cut any artistic enterprise. You just have to study the people, the place, the culture, and do things, and it will be different. And in terms of creating something sustainable, that was absolutely part of my agenda, because I knew that I would have to leave in 5 years. My tenure was tied in with the Director General, who was leaving. So that was always something I did in terms of forward planning and thinking about how to do that, doing kind of nifty little strategic things like signing funding agreements with Pro Helvetia, for example, before I left, with South Korea, all sorts of different organizations and cultural ministries, knowing that CERN, the new Director General coming in, couldn't cancel the program because politically it would look really bad by turning down all these signed things, which I did. So there was a lot of politics and a lot of manoeuvring to make that happen, as well as using the structure of CERN to create a fellowship for a curator to continue the program, which was Monica Bello, who I selected, and she continued the program and has continued to this day, and continued a staff position. And of course, everybody brings their own values and their own approach to any program. So, of course, Monica has created something which is very much within her own character as somebody who's producing, creating exhibitions, and has developed the program further. In my day, I was concentrating on the process and establishing the program and creating something which was very much about exploring and process. Still had created things at the end, but I wasn't explicitly. In fact, I defiantly, at the beginning of launching my program and making everything very impossible, said we're not going to create anything. And that's because I knew we were going to create something, because artists exist to create and make. So any artist will always create something, and so totally by coming to CERN. But I did it as a very strong political statement, because I was very cross that artists were being forced into a box and being forced to, a bit like scientists are now, to predict what they're going to do before they've done it in order to get the funding. And I was like, no, that's outrageous. We've got to take that out of the equation. And so I just naughtily and provocatively said, no, they're not going to make anything, because I knew they would. And they did. So they all did. Every single artist who came through made something inspired by CERN. Yep.
Great, thank you, Ariana. Maybe wanted to pick up on that in a sense, in terms of also the value of your work there. And I think in one of your articles you have this kind of equation that's technology and science and art is culture, and this idea that you need artistic practice to be able to untangle or to think through what technological developments are and what scientific thinking might turn back to society, and I was quite struck as well by ways that you have made interventions within the sort of scientific world, within kind of publications that are really for a science audience, but perhaps you put something within circulated something within a scientific publication in order to also maybe make some space for artistic thinking and artistic practice within those domains. So it would just be interesting to hear a bit more about your thoughts on that. I mean, maybe it was not recently, but if you still, if those are still kind of important to you, if you still kind of stand by that kind of way of describing how these things should sit together.
Yeah, I'm a complete interdisciplinarian, so art plus science plus technology does equal culture, and we all need to stand together. And as I said, we're all about ways of knowing, we're all about ways of exploring and discovering the world. So those barriers should be down, and we should be constantly interacting and talking to each other. It doesn't mean that we don't have expertise, though, and it doesn't mean that every single area doesn't have expertise. I don't believe in the loss of expertise and understanding that people do have expertise. But I think we can all be in the same room together like we are now, discussing different things. So I'm always like that. I'm always about knocking down those walls and creating those spaces so that we can do these different things. So, for example, recently I've been working with a global humanitarian organisation to create something with artists, with scientists, with technologists, with humanitarian workers who are at the forefront of dealing with the humanitarian crises we are in, and creating for them a new kind of laboratory where they can experiment, test and think and imagine, so they're all Imagineers together, what are the new humanitarian causes of disaster which are coming up, because humanitarian workers don't have the time to do these things, to respond to war zone situations, so they don't have time to think ahead about what the new causes will be. So artists, scientists, technologists, humanitarian workers, politicians working together to try and create the space and place to think beyond and think ahead before disasters happen. So they're looking at climate, for example, law, because the rise of law will be creating inequalities globally and will become a new driver of humanitarian crises. So again, there are all these ways we can all work together to actually imagine, and we're back to imagination again, imagine further and create solutions as well as new possibilities. Yeah.
Thank you. We're sort of in the zone of interdisciplinarity now, I would say, and also in the zone of, you've sort of referenced the other people here in the room today that are with us and are thinking with us today. So we will, in a moment, perhaps open up the questions. So if people have a question or a thought that's kind of niggling that they want to share, we'll be moving into that section very soon. But I wanted to just think a little bit together about outreach, different types of outreach, and also different types of and artistic research and artistic practice, and thinking of those as two different things. Look at that. Boom. Thank you. David's technician role is going well. So thinking about how outreach and artistic research intersects with scientific research, and having looked at a lot of your work, Marisa, and in conversations that we've had, understanding the different ways that you've thought about different audiences and different publics that you can engage with your work. And I think it might just be interesting to think about what the sort of nuances of outreach might be, in relation to what artistic residencies and the relationship between art and science might be. Not least because also we're in the Theoretical Physics Institute here, which has a very impressive YouTube channel and YouTube following, which many of us are completely addicted to, by the way. So just be interesting to, what happens for you when you share your research and when you engage different audiences with your work?
So for me, telling the people my work and my research, so it's one of the best things of my work, because I remember why I like so much what I do. And it's really very, very interesting to observe the reactions of the people when you try to explain them how is the world, how is the universe, some of the physics rules. So that depends on the subject you are trying to outreach. But of course, in my case, most of the time is dark matter, and it's really a nice subject to explain. And I think that we have to try to reach everyone that is interested in learning more about science, in this case. I like most working with children, because they are really much more open to different things, and they don't close their mind to different ideas. Adults have sometimes problems, they don't want to believe the things that they don't fit with their schemes. But with children it's really very, very interesting. So I think that the problem is that we have to simplify the ideas, that we have to do a strong work of that is difficult for the physicist, okay? That try to be not completely and perfectly canonical in our explanations, and then sometimes it's not well rewarded by our colleagues, that they consider that you are lowering down the level of your science. So, for instance, I like to make it with children, so some workshops, for instance, in Halloween, that is the Dark Matter Day, and we prepare with candies universes. So we put dark matter, we put dark energy, and we put normal matter. And really the children have a very, very nice time. And maybe some of them will remember this and will think about these things. And okay, I think that one has to find a way to connect with the audience. And there are a lot of possibilities today, so then I think that we have to explore as much as possible. So we did also, recently also in Zaragoza, in an activity with children, a marathon of particles, and we put the children with the name of a particle, and then any particle had different obstacles in the way. And it's really interesting, but the children like a lot these kind of activities. And I think that science shouldn't be so boring. We have to at least try to convince people that we are funny people, that we are really normal people, and that they can have fun with scientific concepts. They can learn, but they can at the same time to have a good time. Yeah.
That's brilliant. I love this idea of building universes from sweets. I don't know if it's the same children that then need to do the race afterwards, but no. I don't know if there's a connection there or continuity. But yeah, thank you so much. That's brilliant. I've also seen some of your work with shadow puppets as well, and telling the story of Vera Rubin, which I think is also really good.
But for that, so of course, we are amateurs and we don't have all the possibilities at our reach, but so for this, the collaboration with artists will be really very interesting, no? Because in this case, we write a small theater, and we do ourselves the puppets, and so okay, it was really funny, but it was not really.
But I think DIY aesthetics are very important and very necessary, absolutely, and also the story of Vera Rubin, and obviously really good to underline the work of female physicists within the development of what we understand or what we don't understand yet about dark matter. What about for you, Ariane? Thinking about art and science together, two very big big words with lots of sort of tributaries underneath them, lots of rhizomes. What for you? How would you describe it as maybe offering something different to other types of outreach or ways that physicists engage with different types of publics?
Yeah, so I'm going to test Davide now and ask him to go back to the Iris van Herpen image, which we put in that one. Yeah. So this is a piece by Iris van Herpen, who is a Dutch fashion designer. It's an extraordinary dress which is made, it looks like a kind of floral bubble. And what I always think about art is it reaches the hearts and parts which science alone doesn't reach. And this piece was actually inspired by her conversations with Subodh Patel, who was talking to her about very, very tiny space-time fluctuations in the stars. And she was so inspired that she created the ultimate dress, which wasn't a dress, which was like a floating, transparent thing. So what I love about art is it indirectly can inspire people to discover more about science. It's not in-your-face outreach. It does it in a much more oblique, much more nuanced, much more subtle way. So people knew that the Aeroform collection, which she did in 2017, was inspired by science, and they kind of look at this, get so excited by it, and it shows incredible technological prowess. She's kind of one of the people who is really taking technology to its fore. They get inspired by looking at like something and go, how did she do that? How did she do that? What inspired her? And then they start chasing the science as a result. So I always think of art as a kind of indirect, can be indirect creative approach to communication and outreach of science. It kind of intrigues those people who are switched off by science. Of course, there are many other different forms of outreach with art and science. You can use art as a tool to reach new audiences in a very much more explicit way by engaging theatre makers, for example, like working with you on the puppets and the scripts. That is another way. Or when you saw, I think right at the beginning, there was a photograph of Gilles Jobin's dance piece, which we did at CMS Detector. We well premiered it there. So actually an audience came, and we did a kind of crossover with the Théâtre de Merin, and we asked them to bring their audience to CERN to watch that dance piece. They wouldn't have come to CERN normally, that dance audience. They came to CERN, watched that piece, and then we took them underground to the CMS detector with some physicists describing the science. That's a bit more straightforward outreach, I would say. That's very straightforward outreach, reaching new communities in a very targeted way. So those are two different ways you can do art science communication. The subtle way, where you get inspired and you go, wow, how did that happen? What was the science behind that? And the very directional way where you get new audiences in very physically, or you get artists in to work with you on a project. Yeah.
Great, thank you. So I think I've been quite indirect about the questions that might be in the audience, but I might be more direct, because I know there are many of you here who are thinking about some of these things, who are also maybe perhaps here in this building for the very first time, have perhaps travelled across Madrid or from other parts of the world to be here today, and it would be really nice to hear some questions from over there.
Ooh, right at the back.
Thank you very much. This was fascinating. So I'm both a scientist and an artist. I paint. But one of the main things that troubles me mostly when I do art is when to stop. So you have imagination, you think you have the techniques to go on and with your work, but then there's a moment when you don't quite know whether to continue on. you're not convinced that this is the way you want it to go. You know, Marcel Proust actually said there are no finished works, there are only abandoned ones. And I'm curious, I mean, where does imagination enter to say, that's it, I'm not going to continue along this quest? And this is something which actually goes to both. So particular to Maria Luisa, so when do you stop searching for particle dark matter? Maybe dark matter is not even a particle. And with respect to Ariane, of course, using imagination to say, we have to finish this work of art. This is no longer going to convince the audience that this is something new. When are we stopping? Is there a way to stop?
I can answer that very quickly. Imagination isn't the mechanism for stopping. I'm afraid you have to use your practical ability and go, this is going nowhere, or I've got a deadline and this cannot continue, or that's enough. Imagination is unstoppable. I always describe it as the untamed beast, which goes beyond and further. So no, it's not the mechanism which is going to help you stop. It's the thing which helps you create, connect, go further. So practical reasons for stopping. And sometimes I always think, like, you have to have constraints. Artists need constraints, actually, weirdly. Otherwise, you could carry on forever because your imagination would just carry on. So you need a practical constraint. So maybe you need to set yourself a false deadline. That might be something. Anyway, that's a reality, yeah, and energy, your own personal energy. Might be finance. You might be wrecking yourself financially by concentrating on art to the exclusion of anything else. Practicalities. So over to Marisa.
So in our case, as I commented before, we know that probably dark matter is not a particle with the properties to be found by us. So from beginning, it was considered that could be primordial black holes or any other thing that could be there, okay? And that was invisible for our detectors. So in principle, I will say that also in science, there are some directions that are more or less preferred by the community. There are many reasons behind. Many times it's because they are possible with the present technologies. And so then the direct detection experiments is true that they develop strongly because they have really a chance to detect a quite wide range of particles that were very good candidates for dark matter. So it's true that they haven't found anything, and that maybe in the next years this could change completely if your experiments have really not a large possibility to detect anything reasonable. So up to now, there is still place for these particles, and okay, so we will see. But in the end, as commented, it's more or less the same also in science. You cannot design an experiment that is impossible. The reality makes the things that imagination is not enough. So then you have to have the money, and you have to have a good scientific case to get funds. So then in the end, this maybe will change in the next years, and there won't be much more money for direct detection experiments if there is not the possibility to find anything interesting. But up to now, what is clear is that it's much more difficult to get to the relevant parameter space. And then the experiments have reduced strongly. There are a few very large collaborations that are funded for the next decade.
I just want to make a warning that even Einstein continued his quest for a unified theory until he died.
You can sit down.
So thank you so much. I found it very interesting. I'm an artist. I work as a visual artist, and I think in my practice I explore the coexistence with the unreal, and I found really interesting like the explore of the unknown. And I wanted to ask, in your opinion, how do you distinguish sometimes a real illusion from a delusion? And I understand that in art we explore this region of the possible, but how does it dialogue with the scientific approach? I don't know if I express myself.
That was perfect. Yeah.
I don't know if I have understood completely what's behind. So in principle, so for us, so we search for possibilities that are allowed for science. So I mean, we have clear what is real or possible. So something that was completely outside our theories, of course, should be very surprising. But should be possible. So I think I don't know. It's complicated maybe to tell the difference what is unreal for us. So because I think that scientists are really very good to identify tricks or these things that you can be cheated by someone because. We know more or less a lot of rules that are governing the world.
But there was that Gran Sasso so-called discovery, for example, which proved to be an illusion, which wasn't real. So how do you do?
But okay, but there are data, of course, and then the interpretation of the data has different possibilities.
Yeah,
it could be dark matter, it could be some failure on the detector. This was also there from the beginning. I mean, you have to search a lot which of the two possibilities is present. And up to now, any of the systematics considered has been able to explain this. But it's true that the collaboration is also not releasing the data, and the transparency is somehow poor. And this is one of the problems also, that you have to have all the data, all the information if you want to derive the right answer or the right conclusion from the experiments. But it's true that in the end science is made by humans, so then it's not free from failure and mistakes. And of course they are happening all the time. And the science has their own methods to try to reproduce and control and to test that the mistakes are not in the final answer. But sometimes this happens also.
Yeah, I guess you have got your parameters that you're working within, and specific kind of calculations that remove it from delusion, I guess, to a certain extent. Although, actually, your question reminded me of the image in one of your slides of, I'm not sure if it's a quark, this kind of green, this kind of green figure with, I don't know if it's got three eyes. Yeah, it's got 3 eyes. Yeah, yeah. So this kind of visual representation that might, that is obviously, I imagine it's not scientifically accurate that we know that it looks like this, but I like the role of the imagination there to be, the illustration can play specifically.
I think that this is good. I use this some times in the outreach because, I'm looking for an invisible matter, and so then how do you know the aspect it has the invisible man, no? So it could be really anything you like. We know how much it weighs, 80 kilograms, 100 kilograms, but we don't know the aspect. But in our case, we also know that it's not something from our normal world. So the best image is an alien. It's an alien that could be green or blue, or 3 eyes or 5 eyes. No idea, because it's invisible also. But of course, it's just a metaphor.
I think Alberto had a question.
Yeah, I just wanted to add to the previous discussion that even if you don't discover dark matter, you are discovering what dark matter is not.
Of course.
And this is an extremely valuable piece of knowledge for the scientific community.
It's true.
And also, when you are, for instance, you are searching for a treasure in a desert island, you don't know where the treasure is, you have to explore everywhere, and the treasure will pop out somewhere, but you have to explore everywhere.
Yeah, this is true. Negative results in science are also not so well rewarded as positive results. This is also a bias that is important. Yeah, but it's true that we have to search for in the places where there is some scientific case, it's true. Sometimes the funds are not for covering everything, but with a focus, I think that of course, if we can search for something that is or could be the answer to a question, then we try. In general, is this.
It was interesting that when you mentioned the Nobel Prize and that it goes to an individual rather than to a team, and I wonder if that will shift over time. That could be a shift that also assists in rewarding different types of collaborative work, and thinking of recent awards within the arts, for example. There have been a number of instances now where they don't go to a single artist, but they're shared prizes that they feel that they need to either give the prize to a collective or to give 3 prizes, to say there are 3 winners this year, because they want to give a greater representation of diversity and equality within artistic practice, but equally to kind of put more value on collaboration and collective thinking.
Thanks for this really interesting event. I have a question concerning the first part, when it was discussed that it sounded like science and arts have the same goal, and they all try to understand nature and get to understand how nature really works. For me, there seems to be a difference between science and art, because in science we look for answers and we will find one, more or less unique answer in the end. Whereas for art, I get the impression you understand nature, you visualize nature, but everybody gets his own answer. And everybody is then happy with his own image of nature or whatever, yeah? Do you agree with this?
Yeah, I would agree with that, totally. I mean, science is predicated on kind of certainty and unity in terms of the answer. And art actually raises just multiplicity of questions. I mean, that's the whole point. It raises multiplicity of questions, and as you say, a multiplicity of answers. There's no one answer. So it's an endless journey of discovery, rather than pinning down to one central way of looking at knowledge. So in fact it opens up the terrain. So when you were talking earlier about science looking at what's not known, ironically art goes all over whatever's not known. That's its territory, it loves it, that's where it exists, that's where it thrives. So that's a difference, a key difference there. Yeah.
On the matter of funding, of course, if you do experimental physics, you have to do a cost-benefit analysis. There is no way to avoid this. Yeah. Experimental physics is actually very expensive, and this is a fact. However, for people like theorists, theoretical physicists, even phenomenologists, or perhaps mathematicians, it should be done like artists, because if a theoretical physicist knew beforehand what he or she is going to do, would have done this already. There is something very wrong in the funding for a branch of physics and a branch of science. That should be done on the basis of previous record. Or, it's not that I have a solution, but obviously the system is ill. Einstein did not make an application because I'm going to discover relativity and then Brownian motion and then this and that. No, this is not the way it works. So there is something very wrong in funding, and we should learn from the artists, or from what the artists are trying to do. There is actually this is not an original idea. There is a very interesting paper by a Spanish physicist who is working in Vienna, Navasquez, who has put that in writing, and I recommend everybody to read this.
Would you like to respond?
No, okay. with respect to funding, there is a lot to say from every part, so from experimentalists and from theorists. So in principle, it's clear that it's not the best system, and probably Einstein wouldn't get a Spanish grant if he tried to. So I cannot say really too much. But it's true that in countries that have a well-developed system, things are working better. So okay, it could be better for anyone. Yeah. It's not easy. So I have not the answer. The how can be decided who project or who should be funded. For experiments, it's more complicated because we need more money than theoretical physicists. But it's true that we should rethink about how to fund research. I will say that it would be good to have basal research funds for the institutions that could be allocated more closely to the researchers. So we are limited by the time. That is not important if your experiment started once or 2 years ago. You have the money up to a date. It's really very, very complicated to manage research. But,
I'm curious about something you said, though, that you felt that theorists should learn from artists, because poor artists work for nothing. Sometimes you don't want to go that route. You do not want to work for nothing. So I'm curious as to what you meant by that.
It might be because earlier I think you alluded to the possibility for perhaps not being specific about an outcome or an output, but I'm curious to hear about that, because none of the funding that I've applied for has allowed me to be not specific about what I would produce. But I think it's a good challenge for a Friday morning to rewrite how funding structures work.
Yeah, it is. And I was on I was a policymaker for the European Commission, working on funding, and we had this discussion within our unit, and I was really saying we have to have open-ended funding where we don't understand or know what the outcome is going to be, that we can experiment. And that was included in the Horizon 2020 programme as a result. So I really believe that funding structures should have the courage, the guts, and the understanding that real discovery and real new knowledge is only founded on the fact of not having strict parameters right at the beginning. We have to create space in our funding structures to do this. And I was pleased that in the end we did that with Horizon 2020. Yeah.
Thank you. That's really interesting to hear, and hopefully that will go forward into Horizon 2030, so we can all go home and write our applications as quickly as possible. Are there any more questions? Yes, Carlos.
Maybe a provocative question. So you show us that science has been inspiration for art during many years, during the whole history, no? You show Maricelli, also Dalí, and many others, no? What about the opposite?
Yeah, art as inspiration to science. Well, Einstein, for example, used to play his violin before he actually thought up some of his greatest theories. So resorting to music or a different way of engaging was a way of inspiring him, and obviously famously he used his dreams as well. In terms of it, what I love though is it's not quantifiable, the direction between science being influenced by art. And actually, isn't that wonderful? Why do we not have space in our society for things we can't measure, that we can't quantify? That there is something about transcendence, things which we can't pin down. But then, having said that, I would say that a lot of the physicists I've worked with, for example, have said that working with the artists has taken them and their thinking into different areas, thinking about new routes rather than the directional route, thinking about how sometimes going off the route of where you want to solve a problem is actually really important, because artists have this wonderful way of going off many routes. They don't go in one route, they go multi-directional, and it can be very frustrating sometimes for scientists in the dialogue because they see this whoosh going all over the place. But that can open up a scientist's mind to actually thinking about new directions. And certainly, for example, theorists I've worked with have said, you're not going to be able to prove this, but I know that my ideas have totally changed. In some way, there's a fundamental little shift inside my head, and I'm sure one of my theories will come out influenced by an artist. And the same with experimentalists. Experimentalists sometimes have been inspired to engage with new materials, actually to prove or be part of their experiments by engaging with artists. So those things are there, but they haven't been tracked. But equally, I would make a plea for the things we can't pin down as well. There's some magic in that, yeah.
Thank you. Another comment is that about the Nobel Prize, the regulations are very clear. It's only 3 people in each field, no more than 3 people, and that's it. If you want to change that, you need to have a new kind of prize. So you need money from Bill Gates or maybe
I just wanted to comment.
From Amancio Ortega, or you can convince them to give a different kind of prize for collaborations, no? Which is something different. No?
The rules could change.
No, because the rules are the rules given by the money of the Nobel Committee and so on, so on, so on. So it's another thing is that about the what you show these kind of boxes in your experiment, no? That you are open and open and open. No? It remembers me the coffins of Tutankhamun, no? That there were several coffins, and at the end was the Tutankhamun.
It's more like one of these Russian dolls. But okay, anyone can think by their own.
Okay, thank you.
Well, it's been quite a morning. I think that just to maybe give a kind of summary, we've decided that we're going to rewrite the Nobel Prize constitution to ensure that it reflects collaboration. And so we'll, if anyone knows any lawyers, then we will get in touch with them. Also rewriting funding, or just looking really carefully at what the wording is in the policy documents of Horizon 2020 and trying to move that into other areas. We've considered the multiple perspectives of nature that can come from artists and from thinking through artistic practices, and how that might cross-pollinate into experimental scientific processes and practices. And many, many more things that I won't have time to recap. But what we can do now is move into a coffee scenario with biscuits and possibly small pieces of tortilla in the other room, so we can continue to have conversations or more informal conversations. I'm sure Ariane and Marisa would welcome any further questions or conversation with each and every one of you. It's worth saying that this is the 3rd of 4 interdisciplinary seminars, so the 4th one will be happening at some point. It's yet to be determined exactly. These are the parameters that I'm working in, but we do have confirmed Alberto Casas as the speaker for the next session, and the other speaker is TBC, to be announced, TBA. It's worth saying just as well, if you're staying here on campus today, there is an event at 5 o'clock, which is the evening of the investigators, and there's many colleagues here working in the Institute of Theoretical Physics who will be in the square sharing their research in different ways, including a quiz where there's the possibility to win a mug, just like one of these ones. And that's going to be from 5 o'clock in the plaza of the University Autónoma campus, which is sort of, if you go that way back towards Canto Blanco, you go through the area where there's some cats, and then there's a kind of big plaza area with some fake grass. Brilliant. So please do join me in thanking our speakers today for all of their work, and also in thanking David and his role as technician, and David and his role as microphone holder. Thank you.